Hello and welcome to Animated Education. Today we are going to talk about units of measure. As you probably already know, we use SI units in physics. This system of measurement is also frequently called the metric system. It's extremely important to use the same units of measure all around the world because scientists from different countries often work together. If they use different units, tragedies that cost millions of dollars are inevitable. For example, the Mars orbiter, designed to orbit Mars as the first interplanetary weather satellite, was lost in 1999 because the NASA team used metric units while a contractor used imperial units. It cost $125 million. Going back to SI units, certain physical quantities have been chosen as base quantities and we are called SI units. These are time, length, mass, electric current, thermodynamic temperature, amount of substance, and luminous intensity. Each has been defined in terms of a standard and given a unit of measure: meter, second, kilogram, ampere, Kelvin, mole, and candela. However, we cannot assign different units to every physical quantity. Therefore, there are units that we call derived units. For example, speed is determined by the ratio that length changes over time. This is a formula of speed: delta S over delta T. So the unit of speed is meters per second. Meters per second. Similarly, acceleration is determined by the ratio that speed changes over time. Delta V over delta T. And the units of measure of acceleration is meters per second square. We do that to basically all physical quantities. They all can be expressed in SI units. Some physical quantities are difficult to express in terms of SI units. For example, work done in SI units, work done is force multiplied by the distance, and we know that the units of force is newtons and the units of length is meters. So the units of force would be newtons times meters. But we know that newtons is kilograms times meters per second square. So this would be equal to kilograms times meters per second square times meters. And this would give us kilograms times meters square over a second square. It is difficult to express this in base units. Therefore, we have SI derived units of work, and it is called joules. This is a joule. Moreover, base SI units are not always practical to use when measuring extremely small or large physical quantities. For example, the distance between the Earth and the Sun, this is Earth and this is Sun, and this is the distance between them, is equal to about 150 billion meters. You could also write it as 150 times 10 to the power of 9 meters, because we have 9 zeros here in total. However, it's still not very convenient to use. So we have prefixes that we can use. And the distance between the Earth and the Sun can be written as 150 gigameters. The most commonly used prefixes are shown in the table. In our daily life, we also use prefixes such as kilometers, centimeters, kilograms, milligrams. These are very common. When dealing with physics problems, we often need to convert units from one to the other. When doing that, we must include units in our equations. Conversion factor helps us to do so. Here is an example, and you'll see what a conversion factor is in a moment. Let's say we have 7 minutes, and we want to know how many seconds it is. X seconds. So, what we should do, you're probably thinking that you could simply multiply it by 60, and well, you would get seconds, and that's basically right, okay? But a conversion factor helps when dealing with a bit more difficult problems. But let's do it with this. So let's say we have 7 minutes, and multiply it by 1. This 1 is a conversion factor. Let me write it another color. This one is a conversion factor. Now, what we need to do is to rewrite this 7 minutes and multiply it by 1, the same conversion factor, but the minutes must simplify. So we write 1 minute here, and 1 minute has 60 seconds. 1 minute has 60 seconds. So 60 seconds here. Now, because you know that 1 minute has 60 seconds, this is basically 1, right? Now, we can simplify minutes here, and we get that this is equal to 7 times 60 seconds divided by 1. And this is, in fact, 420 seconds. Similarly, if we want to convert 420 seconds into minutes, here's what we need to do. We also multiply it by 1, this is a conversion factor, and now we need the seconds to simplify. So I simply rewrite this, 420 seconds, and now here is 1 second, and because we know that 1 minute is 60 seconds, so we multiply it. In our numerator, we write 1 over 60 minutes. Or you could write 1 minute here and 60 seconds here, as you like, it doesn't matter. So, because this 60 now will go in denominator. So we get, I'll rewrite this 420 seconds. Now, this is 1 minute over 60 seconds. You could have written this in the first place. Okay, so now these will simplify, and we get 420 divided by 60 times 1 minute, and this is equal to 7 minutes. Here's how you work with a conversion factor. These examples, they are very primitive, and we often just say that 1 minute has 60 seconds, so we multiply 7 minutes by 60 and we get 420 seconds. However, it is important to notice that essentially we are using this conversion factor. When asked to show your work, you should write an equation with all units included in it and show how these units cancel each other. The last thing that is important to notice while talking about units of measure is called significant figures. They set the number of digits that you can use in reporting your final answer. Here's an example. Let's say in the problem you have two objects. The first object has a mass equal to 1.16 kilograms, and you are asked to find the mass of the second object. Now, you solve the problem and your calculator is showing you that the mass of the second object is 2.54865.421 and so on. Now, when reporting your final answer, you should write it as accurately as it was in the given problem. So you would write that the mass is equal, or the mass of the second object is equal to 2.55 kilograms. That's how your answer should look like. You round your answer up to 2 significant figures after the dot, or up to 3 significant figures in total, because here is a significant figures. They are determined by your problem. So yeah, that's about it for today. I hope you understood and see you next time.